Another series of identities that we could use are called half-angle identities, again derived from some previous identities that we have. And basically what it is, it helps us find the exact angles where the angle we're looking for might be half of something else that we already know. So let's look for an example here and say I want to solve and I want to find what the exact value of 112.5 is, cosine of 112.5. Now, I chose that one because it does fit into half of an angle I know for sure. So let's rewrite it as cosine of an angle divided by 2. So what's its equivalent? It is equivalent to cosine of 225 degrees over 2. And we know the cosine of 225. That's one of those unique angles within our unit circle that we're becoming familiar with. So now from here, I can use my half angle formula to help me get to my ultimate result was to find the cosine of half that angle. So this means then that this results to plus or minus. Oh, you notice there's plus or minuses in each one of those? Well, that doesn't mean that I have two possible answers like the quadratic. Rather, that means that I have to determine the angle sign depending on which quadrant it is in. So the cosine of 112.5, is that positive or negative? Well, it depends on what quadrant. That's in quadrant 2, and we know the cosines are negative in quadrant 2. So because of that, I will pull the negative along with me, and I'll have 1 plus the cosine of alpha, which is my top number, divided by 2. Take the square root of all that. And now we're just going to kind of work our way along as we go. So that's minus 1 plus the cosine of 225 degrees. Oh, sorry, I have a 1. Is a minus root 2 over a 2. All divided by 2, all underneath. Then from here, it's just doing some mathematic gymnastics to go ahead and kind of clean it up and reduce that down a little bit. Let's go ahead and inside of it, let's multiply by a clever version of 1, a 2 over a 2, and let's see if that helps us out here. Two times the 1 gives me a 2. 2 times this negative root 2 over 2 gives me a negative root 2. 2 times a 2 gives me a 4. I don't know why I wrote a 2. Gives me a 4. From there, I can go ahead and split the square root on the top and the bottom. So the numerator will be the square root of 2 minus root 2. The denominator will be the square root of 4. And then I just kind of clean it up a little bit. All over 2. And there's my final solution. So that's the exact value of the cosine of 112.5. And the reason why we chose that particular one is because that allows us to use a known measurement through the half angle identity that we're able to do. And that's as far as I can go. I can probably use some approximations to clean that on up, but that's my exact answer. There's also a couple of half-angle identities for tangent that don't require us to determine what the sign are. And so I've added the two additional ones to the list. With those, let's look at an example of how we can kind of work with one of those by trying to identify or verify this identity where I have the half angle of alpha, the tangent, equals the cosecant of alpha minus the cotangent of alpha. This one's going to be fairly straightforward. I'm going to work with the one on the left, or actually, I'm going to work one on the right. Remember what cosecant of x is? That was 1 over the reciprocal of the sine of alpha. Cotangent, that was cosine over sine. So cosine of alpha over the sine of alpha. From there, I have like terms, or common denominators. So I can rewrite it as 1 minus the cosine of alpha all over sine of alpha. And then if I look at my identity that I have over here, tangent of alpha over 2, the half angle of tangent equals 1 minus cosine alpha sine alpha. So through a way of an example with the two additional identities, we were able to look at this other identity and identity verified.